Hey everyone, welcome to today's edition of Astronomy Daily. I'm Anna.
And I'm Avery. It's Wednesday, August 26th, Series 5, Episode 177.
Today, we're pointing the show at one particular star, and not for a happy reason exactly, but a genuinely fascinating one.
Betelgeuse.
Betelgeuse. Astronomers have just released the most detailed picture yet of that star's actual surface, and bubbling is the word people keep reaching for. We'll spend some real time on why that matters and what it's telling us about how this thing eventually dies.
Then, a spacewalk we left hanging yesterday has a genuinely satisfying ending. The sun threw a solid punch at us overnight. SpaceX quietly broke a reuse record on its way to its 100th launch of the year, and there's a near-total lunar eclipse just 2 nights away that we're talking about a lot, but it is important.
Also, quick continuity note, Roman Space Telescope is now mated to its Falcon Heavy and sitting on pad 39A, 4 days out from Sunday's launch. Nothing new to add today. We'll be all over it this weekend.
Let's get started. First up, set the scene for us. What did astronomers actually just release?
The most detailed picture yet of the actual surface of Betelgeuse, the red supergiant that marks Orion's shoulder, captured with the ALMA array in Chile, that huge network of radio dishes up on the Atacama Plateau. A team led by Bill Dent at the European Southern Observatory put it together, and the images show something genuinely strange, a corrugated, irregular surface with bright hotspots pushing through, like the star's outer layers are actively bubbling.
Bubbling like what exactly? Boiling water, lava, something else?
Closer to boiling, actually. Convection, huge cells of plasma rising and falling, the same basic physics as a pot on the stove, just on a scale that's hard to picture. Betelgeuse itself is enormous, about 20 times the sun's mass, but puffed out to roughly 800 times the sun's diameter. So if you dropped it into our solar system, it would swallow everything out past the orbit of Jupiter. It sits around 600 light years away, and its atmosphere runs somewhere around 3,680 degrees Fahrenheit, with at least 2 hotspots the team measured running nearly 1,000 degrees hotter still than the plasma around them.
1,000 degrees hotter than a star that's already thousands of degrees? That's a serious hotspot.
It is. And here's the detail that actually surprised the researchers. One particular hotspot, up in the northeastern part of the star as we see it, has persisted for more than 7 years. Current models of how these convection cells behave didn't predict anything holding together that long. They're supposed to churn and dissolve much faster. So either the models need adjusting, or there's something else going on holding that structure in place.
Does that where the companion star comes in? You might remember we did a story back a few weeks ago about Betelgeuse having a hidden partner.
Good pickup. Yes, this ties into a separate but related result from earlier this year. Back in July, a team led by Miguel Montargis at the Observatoire de Paris used the VLT in Chile, the Very Large Telescope, with an instrument called SPHERE that's built to block out a star's glare, originally designed for hunting exoplanets, to capture the clearest direct image yet of a faint companion star, now generally called Betelgeuse B. It turned out to be more massive than expected, something like 2 to 3 times the sun's mass, rather than the roughly sun-sized object earlier theories predicted. What Dent's team found in the new ALMA data is that the orientation of that stubborn hotspot lines up with where that companion should be, which supports the idea that Betelgeuse B might genuinely be influencing what's happening on the giant star's surface, rather than the 2 objects just happening to share a neighborhood.
So a hot spot on a dying star might actually be getting stirred by a smaller star orbiting it?
That's the working hypothesis, and it's not confirmed yet, but it's a satisfying possible answer to something that genuinely puzzled the team.
Why does any of this actually matter beyond cool picture of a star?
Because Betelgeuse isn't just any red supergiant. It's one of the closest stars to us that we expect to go supernova. And when it does, it'll be an extraordinary, once-in-a-civilization event, visible in broad daylight for weeks. The honest scientific answer on timing is somewhere in the next roughly 100,000 years, which sounds unsatisfying. But the point Bill Dent made is the one that actually matters here. We don't get to choose when it happens, so the least we can do is document exactly what the star looks like right now, in as much detail as possible, so whenever it does go, we've got a real baseline for comparison. His own words were that its eventual fate as a supernova is exactly what makes it fascinating to know what it actually looks like today.
Building the before picture for an event none of us will necessarily be around to see.
Maybe, maybe not. Betelgeuse has already surprised astronomers once this decade, with that dramatic dimming back in 2019 and 2020 that had people genuinely wondering if it was showing early warning signs. It turned out to be a dust cloud the star threw off itself, not the beginning of the end. But it's a reminder this star doesn't sit still. Every time we get a sharper look, like this one, we're a little more ready for whenever the real thing happens.
A bubbling surface, a hidden companion star, and a countdown nobody can actually read.
That's Betelgeuse for you. Mundane physics, boiling plasma, happening on an object so extreme it barely fits the description.
Okay, happier ending on this one. Yesterday, we left you with a spacewalk still in progress. It's done, and it went well.
It did. Anil Menon and Sophie Adenaut were outside the station for 6.5 hours yesterday, 8:27 a.m. to 2:57 p.m. Eastern, finishing the job they'd started back on the 18th, replacing a space-to-ground antenna that had stopped tracking NASA's data relay satellites all the way back in November last year. Station's been running fine on a backup since then, but redundancy matters up there.
And this time they actually finished it. No running out of time like last time.
Fully finished, pulled the spare antenna out of external storage, mounted it on the Z1 truss, stowed the old faulty one permanently on the ESP3 platform, and got power and data hooked up and confirmed. Mission Control's Anne McLean gave them the line of the day once it was done, quoting an old song at them. "You just saved the video dish. You just saved the video dish," which, if you know the reference, is a genuinely good spacewalk call sign moment.
Numbers-wise, where does that leave these two?
This was Menon's third career EVA. He's now up to 19 hours and 20 minutes of total spacewalk time. And Adenaut's second at 12 hours 53 minutes. And it's worth restating plainly because it's a genuine first. Adenaut remains the first French woman ever to conduct a spacewalk, and that record is now backed by 2 completed EVAs, not one interrupted one. Station-wide, this was the 283rd spacewalk in support of the ISS, the 98th flown in U.S. suits, hence Spacewalk 98, and the 6th of 2026.
A tidy resolution to a story we've been tracking for almost 2 weeks now.
Antenna fixed, record banked, on to the next one.
Meanwhile, 150 million kilometers away, the sun's been busy too.
It has. Sunspot region 4513 has been throwing off flares for the better part of a day now, 5 separate M-class eruptions, and the biggest of the batch peaked yesterday morning at 6 a.m. U.S. Eastern, an M6.9, just shy of X-class, the strongest category there is.
Did we feel anything from that one?
Some people did. That flare triggered R2-level radio blackouts, degrading high-frequency radio communications over parts of Africa, Europe, and the Arctic for a while, as the burst of X-rays hit our upper atmosphere. That part happens at the speed of light, so it's already over. What's still coming is the slower-moving stuff.
The coronal mass ejection.
Right. A CME billowed out alongside that flare, and forecasters have it as a glancing, slow-moving hit. Expected to reach Earth around 6 to 7 a.m. Eastern this Friday, the 28th, give or take about 7 hours either side. On top of that, there's a separate high-speed solar wind stream forecast to arrive starting the 27th. If those two overlap, space weather forecasters are calling for unsettled to active geomagnetic conditions with the chance of reaching minor storm levels.
Translate that to will I see an aurora for people?
Honestly, mostly a northern hemisphere story at minor storm levels. That tends to mean higher latitude places like Scandinavia, Scotland, the northern U.S. states get a decent shot. Not much farther south than that. For us down here, minor storms usually don't reach far past Tasmania on a good night. And we don't have confirmation this one gets that strong. We wouldn't set an alarm for it, but if you're somewhere genuinely far south with a dark sky this Thursday or Friday night, it costs nothing to glance at the horizon.
A flare, a radio blackout, and a maybe aurora all from one cranky sunspot.
The sum's allowed an active week, too.
Sticking with things that happen so often they almost stop being news, except this one's a genuine record.
Yesterday's early morning Falcon 9 launch from Cape Canaveral, 5:33 a.m. Eastern, 29 more Starlink satellites, was SpaceX's 100th Falcon 9 flight of the year. But the number that actually caught our eye was on the booster. B1067 flew for the 37th time, breaking the previous record for flights on a single first stage.
37 trips to space and back on the same piece of hardware.
Same booster, 37 launches, 37 landings. This one on the drone ship a short fall of gravitas, about 8.5 minutes after liftoff. Business as usual at this point. It's not alone up there either. 6 different Falcon 9 boosters now have 30 or more flights each, with B1067 leading the pack. For context on how routine this has become, Falcon 9 alone flew 165 successful missions in all of 2025, more than every other orbital rocket family on the planet combined.
It's funny how 100 launches in a year milestone almost gets buried under a booster's personal best.
That's rocket reusability working exactly as advertised. It's supposed to stop being remarkable. Today's the day the counter clicked over on both fronts at once.
All right, Skywatch. And I know we corrected the record on this one yesterday, so give people the honest version again.
Gladly, because it's worth repeating clearly. The night of August 27th into the 28th brings a genuinely deep partial lunar eclipse. 96% of the moon's disk covered by Earth's shadow, about as close to total as you can get without crossing the line. Peak coverage lands around 12:12 a.m. U.S. Eastern on the 28th, which is 4:12 UTC.
And for us, that converts to
Little after 2 p.m. on the 28th, Sydney time. Broad daylight, moon well below the horizon. This one belongs to the Americas. Good views coast to coast, plus parts of Europe and Africa catching it low near sunrise. Australia and the rest of Asia Pacific are simply on the wrong side of the planet when it happens. Genuinely sorry, again, to anyone who was hoping we'd walked that back. We haven't. It's just not ours this time. If you've got family or listeners in the Americas, it's completely safe to watch with nothing more than your own eyes. No filters or glasses needed like a solar eclipse. Expect the moon to turn a deep coppery red as it slides through Earth's shadow.
And that's the same couple of nights the possible aurora activity we just talked about is due to arrive.
Same window, yes. Thursday night into Friday morning is really the stretch to watch between the eclipse for one hemisphere and a maybe aurora mostly for the other. Tidy bit of overlap, even if neither's really for us here.
So what does that leave for actual Southern Hemisphere eyes this week?
Venus is still the easy win, bright and unmistakable in the western sky shortly after sunset, hard to miss even from a light-polluted balcony. Saturn's well-placed too, rising in the east as it gets dark, and worth a look through binoculars or a small scope if you've got one handy. Nothing as dramatic as a red moon, but a genuinely nice pair to go find tonight regardless.
Venus at dusk, Saturn overnight, an eclipse for the other side of the planet, and maybe some aurora for the far north.
That's the sky this week. And that's it for today's episode. Series 5, episode 177, done and dusted.
Quick recap. Astronomers have released the most detailed picture yet of Betelgeuse's bubbling surface with a stubborn hot spot that may be stirred by a newly confirmed companion star. Astronauts Anil Menon and Sophie Adeneau successfully finished replacing an ISS antenna on their second attempt. The Sun fired off an M.6.9 flare with a CME due Friday and an outside chance of minor aurora activity. SpaceX broke a booster reuse record, 37 flights, on its 100th Falcon 9 launch of the year, and there's a spectacular near-total lunar eclipse 2 nights from now that once again isn't for us here in the Southern Hemisphere.
If you enjoyed the show, the best thing you can do is tell a friend, leave us a rating wherever you listen, and follow us. Just search Astro Daily Pod on Facebook, Instagram, TikTok, X, Tumblr, and YouTube.
And while you're there, head to astronomydaily.io and sign up for our free daily newsletter. A summary of the latest space and astronomy news straight to your inbox, plus an email alert every time we post a new episode.
We'll be back tomorrow with more from across the universe. Until then,
Keep looking up.
clear skies, everyone.